Yeah, folks, am I audible? Uh, okay. Hello again, folks. Thank you very much for joining us on our first online session. My name is Shayok. I'm one of the team members of TensorFlow User Group Kolkata, and a very warm welcome to one and all. So, welcome to this session, Machine Learning on Kaggle and off Kaggle, by a very good friend of mine and also a fellow GD, Akash. He's a research engineer at Ola, and as I mentioned, he's a Google developers expert for machine learning as well. And frankly, he is one of the best ML folks I have met in person. He's an ardent ML researcher too. So this is not a one-man show. TensorFlow User Group Kolkata is not a one-man show. This is the core team that we are looking at here. We have all the core team members present with us today, and most importantly, TensorFlow User Group Kolkata is about the community we have today around here on machine learning and TensorFlow. So here are some coordinates. Please be sure to follow our Twitter page to get updates on sessions like this. Here's our website where we share all the materials from our sessions and any blog post. Also, this is Akash's Twitter handle. He shares excellent resources and collab notebooks and paper summaries on a daily basis. So be sure to give him a follow. So some things to keep in mind. Please be nice with your interactions with your fellow community members, and we'll do a short questions and answers session after Akash is done with his session. So yeah, session brief and materials will be made available here on this link. Again, if you follow our Twitter page, you will be seeing that first thing. So if you have some kind of feedback that you would like to let us know, please feel free to email us. This is our email address. And without any further ado, I'll hand it over to Akash. Akash, take it away.
Am I audible? Hello. So it's giving me a option to send a link. Okay. Hello everyone. Uh, thank you for coming today. Thank you Sayak thank you Sayak and TensorFlow User Group for having me here today. My name is Aakash Nain. I'm a research engineer at Ola, and I've been working in the field of data science and machine learning for more than 3 years now. And computer vision is my favorite field to work with, and this is the area where most of my work is focused on. I'm also an avid Kaggler. I love doing Kaggle. Uh, I love doing Kaggle, and I'm also an open source contributor. I contribute to TensorFlow add-ons, and I am also one of the maintainers for TensorFlow add-ons package. And before I go through my presentation, I just want to say one thing, that the world is going through very difficult times right now, and this is a very critical situation. Please stay home, stay safe. This is good for your own safety as well as for the safety of others, right? Okay, so today I'm going to talk about something that is very much discussed on social media platforms like LinkedIn and Twitter, and especially on LinkedIn. So there are two groups. One group which thinks that you should do Kaggle because it makes you a better data scientist. It helps you polish your data science and machine learning skills. On the other hand, the second group disapproves of this opinion, and they say that you shouldn't spend too much of time on Kaggle because it doesn't mimic the real world scenarios. And given that I have done both the things for a long period of time, so I thought that this would be a good opportunity for me to express my own views on the same topic. So we will be taking a look on how things are different when it comes to machine learning on Kaggle versus off Kaggle. Okay, let's dive in. So before we go into the differences, let's take a step back and understand what Kaggle really is. So Kaggle is an ecosystem that is entirely focused on data science and machine learning. It started around in, if I remember correctly, 2010 and was acquired by Google in 2017. In my opinion, it is the best platform when it comes to doing competitive machine learning. It is also a hub for freely available datasets. There are more than 30,000 datasets as of now. You can download them, you can use them for your own experiments. These are really good small datasets, big datasets, whatever you want. You go there, download it, use it for your experiments. So it's nice. There are also Kaggle kernels, which are now renamed as Kaggle notebooks, which is similar to like Jupyter notebooks, but these are shared by other Kagglers as for the purpose of knowledge sharing. So if you are beginner or if you are looking for something how to start with a competition, these are really helpful. These resources have helped me a lot, and I think they are a great starting point for anyone looking for their journey to break through into data science or machine learning. And apart from that, above all of this, it is the largest data science community that deeply cares about this ecosystem. And I'm very proud to be part of it. And this is something that you all must have heard of, Kaggle competitions. So Kaggle competitions are really fun. The good thing about these competitions is that you get a lot of diversity. So every time you go on Kaggle, there will be many competitions which are running. And the thing is that you can participate into competitions which comes with tabular data. You can participate in image competitions, NLP competitions, speech competitions. So you can get your hands on into every field. This also gives you an opportunity to really see what interests you more as compared to building self projects and then deciding what field you want to choose. So these are really good. And when you participate in a competition, what are all the things that you get? So there is data that is collected and curated by the host. To some extent, it is also pre-processed by the host, and also they provide you the training data, validation split, and the private test split. So you don't have to worry about those things. There are also labels for the training data, right? And again, there are notebooks which are shared by other users for the purpose of knowledge sharing or just how to start with the competition. There is valuation metric, and there is the leaderboard, which is really fun because you can see how your model is performing. You get a score, you get a rank. And I think it is one of the things that motivates you to build more and more models which performs better than your previous models. This is really great. Also there are prizes as well and medals as well. So, and a discussion forums for discussing things related to the competition. So this is what you get when you enter into a competition on Kaggle. But how does the scenario changes when you do machine learning on Kaggle versus off Kaggle? So one of the biggest difference that I think that comes when doing machine learning into real world lies in the data cycle. So data cycle can be really complicated when it comes to real world. And let's see how is it different from Kaggle. So when you're doing competitions on Kaggle, as I said, the data is collected, curated, and pre-processed to some extent by the host. So you don't have to worry about things like data collection, data annotation, right? And because everything is there, you just have to you almost always start with an EDA, right? And then build top models on top of it. So you don't have to worry about things like data pipelines or annotation pipelines or how to automate all these things, right? So most of the workload, and I think this is a very important part of any machine learning project, the data cycle, and you should be involved in this part. But sadly, this thing doesn't exist on Kaggle because the data is collected and curated by the host. You are not directly involved in that process. But when you get in the real world, then things can be really complicated in this data cycle. So you have to collect the data, right? And data collection has a cost associated with it. I'm using the word cost here. I will be using it very often, so bear with me. We will look into why we are talking about cost at every stage in the later slides. So just I'm just adding the term cost here, so please bear with me for the time being. So this data collection has a cost associated with it. Now the cost can be the data collection process can be cheap as well as it can be expensive depending on the kind of project you are doing. So for example, if you are building a chatbot, then in that case the data collection process can be very cheap. So you just have to go through the web and scrape some data, and that's it. You can build your chatbot on top of it. But if you are working for a company, say if you are working for a healthcare company or say for a self-driving car company, then in that case the data cycle can be really really complicated. So for example, if you are working in the healthcare company, then you have to go to the hospitals, you have to collaborate with the doctors, radiologists in order to collect data, and the data is very sparse. You have to go to many hospitals, and this process can be very laborious and time consuming. Similarly, if you are working for a self-driving car, then you have to collect data for different conditions. So for example, you have to collect data for daytime, nighttime, rainy conditions, snowy conditions, right? And this process can go for a long period of time. You can collect data for 6 months, 8 months, years, right? And because every time you are putting a camera or some sensor to collect the data, you are adding a cost to the data collection process, right? So this can be very expensive. Also, collecting data is one thing. You have to pre-process the data yourself, so data cleaning is also required, right? And the thing is that most of the time we are working with supervised learning, so cleaning is one thing, but we also need labels, right? 90% of the time we are working with supervised learning, so you need labels for that. So you need to annotate your data. Now there are three ways you can go and annotate your data. Number one is you can go for Amazon Mechanical Turk, which are pretty famous. The other thing that you can do is you can offload your data to some data labeling company, and they can do data labels. They can label your data for you, or you can employ in-house annotators and ask them to annotate your data. No matter which option you choose, you are adding a cost to your project, right? This data cycle. And for this process to be sophisticated, you want to automate most of the things, right? So for this thing, you want data pipelines, and you have to write these data pipelines. This can be very time consuming task. In my opinion, data cleaning, data collection, data annotation, these three things can consume like 50 to 60% of data science or machine learning project. Also, suppose you have labeled your data, you have labeled your data, and you think that things will go well, but no, it's not. So for example, annotations are done by humans, and humans make mistake, right? So for example, in this scenario, the annotator was supposed to draw a tight bounding box, but the bounding box is not tight. Also, he has left out the cars, so this is a mistake. So the bad thing about machine learning is right now is that it follows the principle of garbage in, garbage out, right? So you want your data to be of high quality as much as possible, right? Also, because as we saw that data collection is can be very expensive, so throwing away data is not always feasible, right? And for this thing that you find out that there are these mistakes, and you need to correct them, so you have to build pipelines for this as well, right? And it also requires verification, which requires human intervention, which again adds cost to the process, right? So these were the major differences when it comes to data cycle. But what about modeling? Like Kaggle is very famous for building models, right? Everyone is building model. What are the differences in this scenario when it comes to real world versus Kaggle? Let's see. So when you're doing a competition on Kaggle, the modeling cycle actually looks like this. There are three major stages. Number one is pre-processing, right? In which you start with an EDA, you do some feature engineering, right? You pre-process your data, you prepare your data for the next stage for your models, for building your models, right? Once you have done this, you go to the modeling stage, right? And now you are not concerned because on Kaggle, no one is forcing you to write a model that works on a particular hardware. You don't have to worry about the production scenarios, right? So there is no hardware dependency. You can choose any architecture that you want, no matter how huge it is. You just care about whether it improves your score or not, and you build many models like this, right? So you build many models, you validate your models locally, right? And make predictions. Also, because you are building so many models, ensembles are very common on Kaggle. You will see that people are stacking like 10 models, 50 models, 100 models, right? So it's very common scenario because they don't care about anything else except for the score and the money, right? That is the main purpose when you are doing a competition on Kaggle. You just want to improve and you want to win the competition. Once you have got your predictions on the validation, once you have built the models, then you do predictions and submit to the leaderboard. You get a score there, then and in the final stage your model is tested again on the private test set, right? And this scenario, suppose you submit your predictions on the leaderboard, you get a feedback that your model ranked this much and your position is this much. You again go back to stage 1 or max stage 2, but this is the cycle that continues on Kaggle, right? Also, the one thing that is very common on Kaggle, and I think it is a very good thing, there is a huge community support. So for example, if you are stuck somewhere, you can go to discussion forums, you can ask people. And the data science community on Kaggle is so good that there are always people who are willing to answer your queries. They will always help you. I have never seen anyone asking anything, no matter how noob the question is, he will or she will always be answered by someone who is expert on that subject, right? So this is really great when you are competing on Kaggle because you have a huge community support. But when it comes to real world, this whole process changes a bit. So for example, you have collected the data. Now on Kaggle, you got the split training, validation, and private test. They have done it for you, right? But in real world, you have to do it yourselves, right? And the thing is, random train test split doesn't work in the real world scenarios most of the time. I am not saying that it doesn't work always, but most of the time it doesn't work. You have to be very careful when you are choosing your validation as well as your test sets, right? And I think people who do Kaggle competitions are very good in choosing their validation sets because they learn how to make good local CV score to match their performance on the leaderboard, right? And this is a really important skill that is most underrated skill on the Kaggle, and people don't realize it how important it is when it comes to real world. Splitting data, doing proper validation is not only just a process, it is an art, and you have to learn that art, right? The other thing is when it comes to real world, hardware dependency comes into picture. Hardware dependency is very real. So for example, I'm giving you a very small example. So for example, if you are building a CCTV solution for your home, right? So and all you have a Raspberry Pi, so you won't be choosing architectures like Resident 50 or Resident 101. You would be looking for smaller architectures like MobileNet, SqueezeNet. The same thing applies to industry, right? You will be choosing your architecture according to the hardware that you have for its deployment, right? So this hardware dependency is very real in a real world, right? And the architect choosing architecture is one thing. Getting equivalent performance on the same architecture and improving it bit by bit is really a hard task. After a point, it's really hard to improve the performance of a smaller network as compared to a bigger network, right? But again, this is very much project dependent, and this hardware dependency is also project dependent, but it will always be there. That's the thing. Also, it's not very common to ensemble models in real world. So I haven't met any person who have ensembled like more than 5 models in production. In fact, 5, I was even surprised for 5. But so yeah, ensembles are not very common in real world. And now you must be thinking, is that all? Like, these are the differences that I was waiting for to look into, right? But no, there is more. Of course, there is more. The thing is, when it comes to real world, the test set keeps changing. On Kaggle, you have a fixed set, but in real world, the test set keeps changing, and you have to build models you have to build models that are robust to these changes, right? And you have to build models again and again and again to incorporate more validation sets, right? And to improve your performance. Also, when you are deploying your model for the first stage, for the initial stage, or I can say A/B testing, you have to capture every event. where the model's prediction were right, whether they were wrong, or why it was wrong. You have to capture all these events, and you have to validate your model, right, on the in the real world, right? And this validation again requires human intervention, and whenever there is a human intervention, there is a cost associated with it, right? So deployment issues are also common, deployment issues are also common, as in software engineering. Machine learning engineering also comes with those deployment scenarios, and it is, to some extent, it can be very much time consuming at some point, but again, it depends on the project. But there are things that makes the real world much harder as compared to other things, and in my opinion, these two things are those things that makes it much more harder to build and do machine learning in real world as compared to doing machine learning on Kaggle. Number one is business constraints. So you remember that we were adding the term cost to every stage when we were talking in the earlier slides, right? So the thing is, when you go and explain something to your boss to build, when you want to build machine learning models in real world, there is a cost associated with it. For your project, there would be a budget that is decided by the business, right? So budget drives a project, not your cool tech. It doesn't matter to the business whether you use classical computer vision approaches or you do deep learning. They just care about the inputs and the outputs that they are looking for, right? And for this whole thing, there's a budget allocated to it, right? Also, budget is one thing, but what the business is looking at, what I am gaining after this thing. So if you are building something for your company, the company would be looking for gains, for savings, right? So for example, if you are building a model that can save 2 lakhs or 5 lakhs per year for a company, but if the spend but the if the spend that has gone into this project, so for example, data collection has a cost, data annotation has a cost, then there are ML engineers who are building. So all these things, suppose it take 4 to 6 months, then does this cost that the company has spent on you, the resources the company has spent on you, does this cost justify the gains that the company is having, right? And if the project is not very long term, so for example, if the project is not going is not meant for like 5 to 10 years, and you are saving only 1 lakh or 2 lakhs per year and spending like 30 lakhs in the first year for building that model, does that really justify the business purpose? To big companies, maybe. To smaller companies, no, right? The other thing is timelines are very hard to negotiate. So when you are dealing with business people, they want outputs, and they will be asking you questions on after every like weekly, monthly, or bi-weekly, bi-monthly, right? What is your progress, right? And the bad thing about machine learning is it's very hard to give estimates, right? So suppose you estimated that data collection would take 15 days or 20 days, but the amount of data that you collected in 15 days was not sufficient, right? So you have to extend the timeline. But giving that explaining that thing to business, that the timelines has to be extended, can be really hard, because every time you extend the timeline, you are adding a cost to the company, right? And they are very much concerned about that cost. The other thing is that the resources are very constrained. So when you are doing competition on machine learning, nobody cares about whether you use DGX1, whether you use 1080 Ti, or whether you use your own GPU like P100, or any GPU like P100 2080 Ti. It doesn't matter, right? Kaggle only cares about what the model that you build, you provide to them. If it is really good, that's it. Resources is not something that is very much discussed on Kaggle, right? But when it comes to real world, suppose you are building something for your company, suppose you are building an OCR solution, right? You just can't ask your boss for a DGX1, right? The resources are very much constrained. Also, as I said, ML engineers are not very cheap. So there is also a cost of hiring many machine learning engineers, and again, this cost adds to the cost of your project, right? The other thing is model explainability. I think this is, in my opinion, when doing especially doing a deep learning, these things can be very hard when it comes to real world. So because business have a very technical business have a very limited technical knowledge, right? They don't understand what weights are, what biases are, or what batch normalization is, right? And they don't even care about it. They care about the inputs and the outputs they are looking for. So explaining things to business can be really hard. So for example, if you are building a self-driving car, right, and you are just using the cameras and there was a person on the road who was not detected, and you hit the person and there was an accident, huge accident. Now in this scenario, life is at stake, right? Your boss doesn't care whether you use neural network or which neural network, right? There was a fatality and you are answerable. Why the person was not detected, right? And the bad thing is, when it comes to machine learning, the machine learning models are almost black box, right? There is no easy answer why a model behaves the way it behaved, right? So you have to develop some communication skills to communicate this idea how things work to the business in a simpler way, in a way that they understands, right? Because technical jargons are not for them. They want simple answers, and if you can convince them, then it's fine. If you don't if you are not able to convince them, then you would be out of your job very soon, right? And no matter what happens, don't be that third guy in the room. So there is this conference room where your boss is asking why the person was not detected, and this person said not entering it, which is really not acceptable because it was your job, right? So these two things, like business constraints and model explainability, is something that comes very often in picture when it comes to real world machine learning. On Kaggle, these are not discussed very much, and they don't care about that much. But these are very much real in real world scenarios, and you have to develop these skills at some point in time if you really want to become a good machine learning engineer or a good data scientist. That's it from my side. Thank you, folks. And this is my Twitter handle. If you want to follow me, I share good stuff. If you like it, just follow me there. No, that's it. Thank you. Thanks a lot.
uh, I
Hey, Sai.
think, yeah, I think we can do the Q&A now. So while Akash is here with us,
Yeah, sure.
we can go for the Q&A. So yeah,
Yeah, sure.
let's hit it hard. Yeah, Akash, if you could take a look at the chat, you will
Mhm.
have
Yeah.
the questions. Yeah, Jack Martin, I guess he's the first one.
On YouTube you are saying, or in this?
Yeah, yeah, on YouTube.
Okay, can you send me the link again? And this here I just close the window.
Yeah, yeah, sure, sure, sure. I just sent it over on WhatsApp. Yeah, cool.
On WhatsApp or
Yeah,
email?
yeah, on WhatsApp.
Just give me a sec.
Yeah, yeah.
Actually, keep my phone away when doing technical things, so I have to
Yeah,
grab my phone. So
yeah,
sorry
yeah.
for this.
Yeah, no, no issues.
Okay. Yeah.
Yeah.
So what is the first question?
Yeah, the first question is a question for Akash. Why there isn't a YouTube channel run by Akash for explaining concepts more deeply?
So the thing is, I don't get much time to do these things because most of the time I'm spending my time on research. So I really love to contribute to open source and doing things which are like there are almost 100 papers every day, right? So I have to cope up with these papers in order to remain in the field if I want to be among the best ones. So I don't get time to do these things very often. So, but in the future, maybe.
Yeah, but Akash is an ardent writer. He's quite active on the research paper summary thing. So be sure to follow Akash on Medium if you do not want to miss out a paper summary from him. The latest one is on SimCLR, the great self-supervised framework proposed by Hinton and his group. Is that correct, right?
Yeah.
SimCLR was the
Yeah.
latest one.
SimCLR
Yeah,
was the
cool.
latest one.
Yeah, I do follow this guy quite closely. So yeah.
Thanks, Eric.
So yeah, of course. The second question is from wait a sec is from we are just getting lost, man. Yeah, it's from Akash Anand.
Mhm.
Sometimes Kaggle is too overwhelming for beginners. How to deal with it? How to get most out of Kaggle for budding ML enthusiasts?
See, the thing is, you shouldn't be afraid to ask questions. This is the first rule, right? You have to start somewhere, right? I know it can be very overwhelming to deal with everything that is going on in the machine learning field. There are so many papers, so many different techniques coming out every day. But start with the basics. As I said, that there are so many notebooks they are shared by other Kagglers. Start with them. Don't get into this thing that you have to become a good data scientist in 10 days or 15 days. It takes time. Just spend time into it and you will get it.
Uh, Thanks for your answer, Akash. So the next
Welcome.
question comes from Vishnu. He
Mhm.
asks, "Can I know what is a data pipeline?"
So, for example, if you are collecting data for a healthcare company, then in that case, you would be checking. This is a very little example. If you would be checking, like, if the X-rays, suppose you are collecting X-rays, so if the quality of X-rays are fine or not, and is it relevant to your section or not? Because it can be when it comes to data collection, data can be very noisy. And similarly for self-driving cars, when you are collecting videos and data from other sensors, you have to pre-process those data. So you would be building pipelines for those things to extract data as much as possible. You just simply can't run your program every time to extract those things. So you want a pipeline that can automate this task, right?
Cool. So, if you could, share any resources that can help them to hone in their data pre-processing or data pipelining skills in general, please feel free to,
Sure.
go
Okay.
ahead.
I will do a simple project where I can show this thing to people, and I will put it on GitHub.
Yeah, cool. So for that, folks, you need to follow Akash on Twitter because I think he is the most active person there. So he keeps on sharing good stuff on Twitter. So be sure to follow him. So Akash will take another 3-4 questions. So is that okay?
Yeah, sure.
Cool. So the next question comes from Praveen. He asks, "What process is used to monitor team/individual progress? Can Agile fit?"
Actually, that depends from company to company. I think it is very much dependent on the kind of communication that is happening within your team. So, for example, if I talk about my team, then we keep posting what we have done today and what we are going to do in the next week. So, but it is very much team dependent how the communication happens there, how you are tracking the progress of each other. So, this is very much team dependent thing. Yeah.
Yeah, thanks, Akash. So the next question comes from Orithro. He asks, "Akash, what is particularly meant by data cycle?"
So data cycle consists of 3 to 4 processes. Actually, it is a collection. It is a two-stage process. The first one where you collect the data, and the second one where you process the data. So in data collection, you would be collecting raw data. In the second stage, you would be pre-processing that data and labeling the data. As I said, 90% of the time you would be working on supervised learning. If that is not the case, that is different thing. But most of the time, these are the two stages that happens in the data cycle.
Cool. Probably the penultimate question. So this question is from Cool Ninja. I don't know. This is the username that I saw. But
Okay.
the question is, do we use traditional ML model in production at all, or all are deep learning models?
Again, very much dependent on the kind of project you are doing. Or so for example, if you just want If you are building a model for named entity recognition, then I think you don't want to get into deep learning. You can do that with trivial methods, right? So it is a very much this question is very much dependent on the kind of project that you are doing. So if I talk about, say, if I want to do object detection or semantic segmentation, then probably I would go for deep learning, because they are much better methods as compared to trivial machine learning methods.
Yeah, I think the same too. I just wanted to share my sense here. I think it's more alchemy than science. But yeah, there's a thing called guided experiments. You should be knowing what's the better cavalry or what's the better machinery for accomplishing a particular task. So just
Yeah.
adding on top of just what Akash said, this is where having more and more knowledge about your crafts and chops come into picture. If you know about classical computer vision, for example, you will be able to utilize those lightweighted approaches, and you might want to prefer those when it's needed. So yeah, it's again a very win-win situation when the vocabulary or the knowledge of the entire stack is quite deep with you. So that
Also,
absolutely
yeah.
helps. Yeah.
So also there is one more point that when we talked about the cost budget of the project, right? So you can actually check if the output that the business is looking for, can you achieve this? Can you achieve that with trivial machine learning? If that is fine, then do it with traditional machine learning. No one is stopping you, because the business don't care about whether you use classical machine learning or whether you use deep learning. It doesn't matter to them.
Okay. Yeah, I think I absolutely uh, agree with the things. And the final question of the talk. So this is coming from Amitrojit. He's also from Bangalore. He's
Okay.
from Kolkata originally, but he's one of my juniors, so I know him. What do you think about accuracy in terms of Kaggle versus real world?
Mm, accuracy is a very vague term actually. So can you pose your question in a better way? I don't think like I can answer this with accuracy. What do you mean by accuracy here? If you can elaborate that, then I can answer it in a better way.
We are waiting. So yeah, so meanwhile, we got another more important question, I feel. So this is the one that is coming from Santosh.
Mhm.
And this is going to be the last one. Tell us about a time when you were asked to explain the false positives slash failure of your model at work and how you managed. Any generic tips slash guidelines for handling such
Okay.
scenarios?
I won't be able to give you all the details, but I would give you enough details so that you can know. So, for example, I was working on a healthcare dataset with some of my teammates, and there was one particular guy who was asking to build it for him. So, so when we were building the model, so the thing is, when it comes to healthcare, cases can be very critical, right? So if some patient is sick and you are saying your model is saying that he or she is not sick, then it has a very dangerous consequences, right? So when we were deploying model for the first few days, I actually, every time I was sitting with this guy, and I was actually checking every result that was coming out of the model, right? I have to validate it myself. And if something was not as expected, then we were diving into our models, our pipelines, that what went wrong, right?
Yeah, I
For
think, yeah,
See,
Akash, go ahead.
regarding guidelines, I think this is very much, again, project dependent thing, right? Some projects can demands more human intervention. Some projects can be automated, right? For this thing, right? The performance can be automated to some tasks. Some requires human intervention. So again, this is very much project dependent, and I don't know how to provide you some general guidelines, because there are none. It is very much team dependent, project dependent. So yeah.
Yeah, Akash, thank you for your talk again. I mean, it's coming from the entire TensorFlow User Group Kolkata team, and also for your information, Sonsun was also here.
Oh,
So
okay, nice.
he expressed his gratitude, and Biswajit from the Google India developer relations team was also here. So I think it was a win-win talk, and we are looking forward to have you in our future sessions if your time permits, because we know, of course, you are
Yeah.
absolutely delved into the research area and stuff like that, and it was our indeed pleasure to have you. So if you could, quickly give your coordinates to the participants so that they can follow your work and reach out to you. Yeah. So
So
this is, yeah.
the only platform that I am active on is Twitter. I mostly share stuff on Twitter as well as on my Medium blog. So if you want to get some information, you either contact me on Twitter or you can contact me on my. So there is one Kaggle Slack that we run. It is known by the name Kaggle Noobs. Although the name is a misnomer because it is one of the best Kaggle Slack out there. So you can join that Slack. I will provide the link to that Slack here only. Just give me a sec. I will put the link in the chat and you can message me there.
Yeah, so the folks that are asking what was Akash's, how did Akash start his journey and stuff like that. I just posted a link to an interview that I did with Akash. He has mentioned all of those things and what are the kind of capstone projects that he did. You can know all of those stuff in that interview. So yeah, I thought of just saving some time for Akash.
Yeah. Thank you, Sayak. Thank you,
Yeah,
TensorFlow User Group, and thank you, Google Dev Experts, for having me here today. This was a fun session. I hope I didn't bore you much.
of
So
course.
if there is anything, you can ping me, and I would do my best to answer your questions. Also, one more thing. Again, I'm saying this again and again. When you are starting in data science and machine learning, things can be very very overwhelming, but don't be afraid to ask questions. It is okay to ask question, and no one is going to judge you. Ask it. If you are not asking questions, you are hindering your own progress. No one is going to blame you for that, right? You yourself are responsible for your progress, hindering progress, right?
Absolutely. I mean, I'll just share my story here. 2 days ago, I asked Akash questions on his implementations, and he was, generous enough and kind enough to answer all of the questions I asked him in a very formidable way. So, thanks, Akash, once again, and I hope to see you all in our upcoming sessions. Thank you.
Thank you. Thanks a lot.
Chalo, bye.
Bye.
Yeah, folks, I'm back again. No, for not taking another session. So uh, every details of this session will be made available on this link that I just mentioned. It will be made available on this link. Be sure to give it a read And yeah, you can follow Akash on Twitter and asking questions that were not covered on today's session. And thanks again for joining this session. And please be safe out there. Stay safe and stay well. Take care.